Hello, statistics students. I'm Professor Ken, and today I'm down on the farm with all these crazy wild animals. Anyway, I promised you I would make a video to go along with the final practice document, which I am now doing, and I don't think I've sent out the final practice document, but that's okay. I'll make the video anyway, and hopefully you can follow along. All right, so let's share. Okay, and I'm going to stop the video. It should still be recording. I'm not sure how I know if it's still recording or not. Let's see. Just want to make sure it's still recording. Yes, it is still recording. That is a very good thing. All right. So I stopped the share so my good looks won't get in your way. And right here, now we have, look, final exam practice with the key. Well, there's no key yet because I'm going to make it now as we go along. And I just realized it might be best if I print out a copy. Oh, never mind, I won't. Okay. So going back up. All right. So below is a table of foot length in millimeters and weight of a person in kilograms. What's the linear regression for foot length and weight? Don't use X and Y in your final answer. All right. So we're going to go on to Desmos. We're going to learn together. And I'm going to add on what's called a table. All right. So the X1 values are going to be our foot lengths. So let's go over here. Now we have 282, 278, 282, 278. What's the next? I'll do two at a time. 280, 253, 259. 253, 259. 279, 258. 279, 258. 274, 262. 274, 262. And then finally, 270. Okay, I hope this is helpful for you. All right, now our Y values, which are weights. I want that. Okay, that's what I want. Okay, so we have 198.90. 198.90. And then we have 92, 99, 91. 92, 99, 91. And then we have 97, 93, 95. 97, 93, 95. And it looks like we don't have any of our points plotted, but that's because our X values go from 253 to a little over almost 300. So let's go to our wrench and let's make our smallest X value 250 and our biggest X value 320. Let's make our smallest Y value, they go from about 90 to 100, so maybe 80, and our biggest Y value 110. There they are. And we could see that it falls pretty closely into a line. So what we want to do now is find the line of best fit, which is also called the regression line. So that's Y equals MX plus B. But we're not going to use Y, we're going to use Y1. So copy that. And we say Control V, Y1. Now, we're not going to use equal, we're going to use the tilde, which is that. Then we say M, we use X1 plus B. And here we have it. Now, oh, it should be X1, not Y1. It didn't come up. There it is. Wow, looks pretty good. And we see that the R value is 0.99, which means it's a great correlation. Okay, it predicts it extremely well. So what's our regression line? Okay, it's going to be y equals 0.345 x and then plus 2.37. Okay, I'll turn this one off so we can see our regression line better. All right, so what I'm going to do, just to make it easy, I'm going to just copy this. And I'm going to go right here and paste it. Okay, now I'm not done yet because it says write the linear regression for foot length and weight. Don't use X and Y. So weight is the Y coordinate. So our final answer is going to be weight is equal to 0.345 times foot length plus 2.37. And I would say that should be circled. So we're going to insert a shape. It's a circle. And I'm going to have no fill. Okay, there, our final answer is circled. All right, now, based on the regression model, if someone's foot length is 310, what is their expected weight? So remember that 310. Let's go back to our Desmos. So now we're going to let x equal 310. So it'd be 0.345 times 310 plus 2.37. And that'd be 109. We expect it to be because 310 is bigger than all these values. So I can just go like copy that, do a screenshot of this little area, paste it here, and then finally say we would expect the weight to be 109.32 kilograms. Okay. Let's go on to B now. All right. Listed below are the mean speeds in miles per hour for greyhounds who race on a track. Sparky the Greyhound runs at a mean of 38.8 miles per hour. Is the mean for the 15 Greyhounds listed significantly more than Sparky's with 0.01 significance? All right, so what we're doing is, we're doing a null hypothesis test to see if the means of the Greyhound are significantly more than Sparky's. To see if, so the claim is that mu is greater than Sparky's mean of 38.8. And alpha equals 0.01. And now we need to know the, n is equal to 15. And we need to know the x bar, which is the mean of the sample. And we need to know x, which is the standard deviation of the sample. So we can go to the appropriate Desmos, which is a null hypothesis test for means, and we'll calculate that stuff. All right, so here's our Desmos link. Null hypothesis test for means. There it is. Okay. So the first thing we probably want to do is go to the bottom and calculate our mean for those values. So I'm going to have to put in those 15 values. I'll do two at a time, 40.3, 39.6. I wonder if I could just paste them, copy and paste them. I doubt it, but wouldn't that be beautiful? Oh, dear God, it worked. Well, not really. Let's see what happened, but at least we got some numbers in there. Okay, so what it didn't do was it didn't put in the commas. So we'll put in the commas, which is a lot easier than copying it one by one. Hopefully I don't need to have a space after these darn commas, because then I'll have to go put spaces in later on if it's not going to let me. Ah, it did it. Okay, so we have a mean of 40.22, and let's copy our standard deviation because we're going to have to know that too. All right, so let's copy all these bad boys. Copy it, paste it here. And our standard deviation is 0.654. All right, beautiful. So let's go up above now. So our alphas, let's make sure alpha's 0.05. I don't remember anymore. Alpha's 0.01. And was 15 greyhounds we tested. And the mean of the claim, the population, is mu. .38. That would be Sparky's mean speed. So mu equals 38.8. All right, M is our, we don't want to, M is our X bar, which is the mean of our sample, 40.23. And our standard deviation was 0.654. Now, this is a one-tailed test to the right. Well, let's see if it's right or left. Let's go back and look at this question carefully. All right. Is the mean for the 15 greyhounds more than Sparky's? All right. So now we're ready to do our null hypothesis testing. Two. The null hypothesis is that mu is greater than 38.8. So it's a right-tailed test. And number three, the alternate hypothesis is that, oh no, null is always equals. Gosh. The alternative that we're trying to prove is that mu is greater than 38.8. Because if it's great, if those 15 have a mean greater than Sparky, Sparky's getting put out to the pasture. And we all know what that means. Pasture ain't no pasture. All right, so the alpha value is 0.01. All right, let's go back to our Desmos. So we want to make sure the okay, it has an area of 0.99. That's good. And our, all right, so we have our critical value of 2.62. And we have our test statistic of 8.5. Beautiful. Let's just make sure everything looks okay. And it seems to me. So now I'm going to do a little draw. All right, so we have our T. And down here is our mu. So this would be 0. This would be 38.8. 0.01 out here and 0.99 in here. Our critical value and we could also graph t if we want. I kind of like that idea. Little t, comma, 0. There it is, 2.62. And our big T is equal to 8.5. All right. So this was number 4. All right. And over here we have 5 and 6. All right, let's go to the next line because now we have enough info. Woo, didn't want to do that. All right. I want to scroll down. All right. So now we have enough information to make our decision. So we're going to reject the null hypothesis if our t value is greater than 2.62. We're going to fail to reject the null hypothesis if t is less than 2.62. Well, what is our t value? Our t value is equal to 8.5. So what's our decision? To reject the null hypothesis. And what does that mean in terms of the alternative? Okay, the alternative hypothesis is that the mean speed for those 15 greyhounds is greater than 38.8 or more than Sparky's. So step 9, the mean speed for the 15 greyhounds is greater than 38.8 or greater than Sparky's mean speed. Do not race Sparky. He too slow. Okay, there we have it. Let's go on to the next one. Number 3. All right. Test with 0.05 significance whether the standard deviation of the greyhounds is more than 1.0. All right. So in number 1, okay, part 1. It's not letting me do part 1. I'm so about to say number 1. All right. What do we know? That alpha equals 0.05. That S, which was the standard deviation of the sample, I have to go back to the Desmos, was 0.654. Sigma, which we're testing it against, I might have spelled that wrong, is 1.0, but that's okay. And n is equal to 15. So what are we trying to test? Whether the standard deviation of our sample is more than 1.0. So therefore the claim is that sigma is greater than 1.0. All right, so we're ready to do our null hypothesis. Is that, I'm going to go over here because I like to do it right. Sigma is greater than 1.0. No, equals the null hypothesis. Oh my gosh, I did it again. Okay. So our alternative hypothesis, I'm going to do a little copy because I'm going to do that one a lot, is that sigma is greater than 1.0. Our alpha level is 0.05. Might as well. Alpha equals 0.05. And it's going to be a right-tailed chi-square test. Okay, so how do we do chi-square? Well, we're going to have to do an equation. Greek letters, somewhere around here usually. Come on, chi, where are, oh, there it is. Chi. So it's a right-tail chi-square test. Okay, so now we need to go to find our correct distribution. So we go to our Desmos list. This is a null hypothesis test for a standard deviation. Null hypothesis test for a standard deviation. There it is. Okay, so our n value is 15. The standard deviation of the sample is 0.654. The claim is 1.0. Now, it's a right-tailed test with 0.05 significance. So that means the area to the left of the right partition is going to be 0.95. The area to the left of there's not going to be a left partition because it's only a right-tailed test. So our chi-square critical value is 23.7. So we'll go to draw. We'll make our chi-square. Remember, it's got to look like a roller coaster or a whale. All right, so over here, this is 0.05. This is 0.95. This is 0. And 23.7. This is 23.7. And somewhere we're testing over here, 1.0. All right, and what's our test statistic? 5.99. All right, so now that was steps 5 and 6. So 5 is really come up with that critical value, and 6 is you come up with the test statistic. Right, so now we're ready for part 7. Part 7, we reject the null hypothesis if the test statistics for calling chi-square, I want to do it right. Control copy. If chi-square is greater than 23.7. We fail to reject the null hypothesis if chi-square is less than 23.7. Well, what do we know? Chi-square is equal to 5.99. Now, 5.99 is less than 23.7. Therefore, we failed to reject the null hypothesis. So in step 9, what's our final decision? All right, we were trying to prove that the standard deviation was greater than 1. So there is not enough information, evidence to support that the standard deviation for the speed of greyhounds is greater than 1.0. And we are done. All right, number 4. Out of 100 children exposed to secondhand smoke, 20 developed asthma. Out of 135 children not exposed to secondhand smoke, 10 developed asthma. Use a 0.10 significance test if children exposed to secondhand smoke are at greater risk of developing asthma. So we're comparing two proportions. So we're gonna have P1 and P2. So the first is going to be exposed to secondhand smoke. What do we know about those people? All right, so N1 is equal to 100. 20 developed asthma. So X1 is equal to 20. That means P hat, not fat 1, is equal to 20 over 100. Okay, how about not exposed? All right, there's 135. So N2 equals 135. 10 developed asthma. So X2 is equal to 10. And P hat 2, not fat, is equal to 10 out of 135. And our significance level is 0.10, not 0.01. Be careful. Alpha equals 0.10. And we're trying to see if children exposed are at greater risk. That means the incidence of asthma in those exposed is greater than those who are not exposed. So really, we're trying to prove that. My goodness gracious. So the claim is that P1 is greater than P2. So then now we know it's going to be a right tail z-test. All right, so the null hypothesis is that P1 minus P2 is equal to, did it again, 0. The alternative is that P1 minus P2 is greater than 0, because P1 is those exposed, P2 is those not exposed. We want to say those exposed are greater than those not exposed. 4. Just that 4. Alpha equals 0.10. All right, so now we're ready to put in our data. So we're going to go to our Desmos, and this is a null hypothesis test with two proportions. There it is. Okay. So since the right tail test, we're going to be going from negative infinity to z. Our alpha is 0.10. So let's have a look here. All right. All right. So our area here is 0.95. We don't want that. We want 0.90. So let's get rid of this alpha over 2 because it's only one tail. There we go, 0.90. There's our critical value, which may change because we didn't put in our information. Okay, so P1 hat is P hat 1, 20 over 100. P2 hat is 10 over 135. All right, now, so N1 is 100. N2 is 135. X1 is 20. And X2 is 10. All right, so our test statistic is 2.8. All right, so we got everything we need to know. All right, I'm actually going to go like this because I can. So this is now 5 and 6. Paste it in there. Okay, so we already know our Z critical value, and we know our test statistic is 2.86, but I'm going to draw that anyway. So I'm going to say Z equals 2.86, even though it's right there. Okay, now we're ready to set the rules of the game. Look at that. Okay. So for step 7, we reject the null hypothesis if Z is greater than 1.28 and fail to reject if Z is less than 1.28. All right, what's the value of Z? Well, Z equals 2.86. Therefore, we reject that null hypothesis. So what do we claim? What's our claim? Okay, let's go back to the alternative. That P1 minus P2 is greater than 0. That means P1 is bigger than P2. So the proportion of children who develop asthma, if they're exposed to secondhand smoke, is greater than those who are not. So oh my God. What am I going to do? Oh, okay. Auto save. Let's get rid of that. I don't know what's going on here. Horrible. All right. I am going to stop my recording